might be beneficial to you to look at a question like this and just for yourself, like identify what's happening to the graph, right? So, and if I don't ask for the formal terminology, I don't need you to write all the formal terminology. But if you wanted to jot down some stuff for yourself, it's more than welcome. Okay. So I'd say for this one, what is that out front of the function? Is that out front, Gabe?
A.
It's a. So it's well, yeah, it is a, and a is -1. Okay. And so that means it's been reflected vertically. Okay, that's the first thing I see. Now, what's the next thing? The 2 on the inside. What's that 2 on the inside, Dylan? It's kind of, but it's, if it was a line, it would be kind of like the slope, but it's not. It's not a. That is not a line. It's a bunch of lines. So what is that 2 representing, Sylvie?
K.
It's the K value. And so it's 1 over K we know to be, because on the inside it's 1 over K. So it's a horizontal compression by 1/2. Okay. So horizontal compression by 1/2. Okay. And then the last piece on the end, what letter is that? Or what variable, if you will? Owen?
Vertically translate up one.
Yeah, so it's the Q value, right? So we're gonna say vertical. You don't need to. You can just say vertically translate. Well, I guess it's good just to be in the habit of writing the terminology. I'm not gonna. If I don't ask for it specifically, I'm not gonna hit you with taking off marks with any sort of like incorrect use of terminology. But why don't you just get in the habit of just writing it all the time up 1 unit, okay? So we're just gonna follow exactly what it's been asked to do, right? So we're gonna reflect it, then I'm gonna compress it, then vertically translate it up 1 unit, call it a day. That's it. So 3 transformations, right? So the reflection, if we wanna do the reflection, we'll do in red, okay? So +4 turns to -4, 0 stays at 0, 3 turns to -3, 1 turns to -1, and -2 turns to +2. Okay, that's the first one. Everybody see that? It's okay. So that's the reflection. The horizontal compression now. So I'm going to compress the graph, so I'm going to cut the x values in half. Okay, and that's going to be the blue graph now. Okay, so this is 4 units away. If I cut 4 units in half, it's going to come to here. 2 is going to go to 1. 0 stays on the 0. 2 goes to 1. And 4 goes to 2. Okay? Are we happy? And one more. Big part of this is just identification of what's in the equation, right? I think everyone's probably confident enough to like reflect something like the mechanics piece. I think everybody's okay with, is my impression, or would be the logical conclusion that anyone would come to. Okay, I think we can cut some stuff in half, like reflect horizontally, vertically, move up and down. I don't know if that's the challenge of the question. I think it's the identification of what's what. Okay, so now we just move them all up 1. That'll be the purple graph. And our final graph, up 1, up 1, up 1. Oh, sorry, of the blue graph. Sorry, I was doing the wrong graph. Up 1, up 1, up 1, up 1, up 1. Okay, so that purple graph's going to be your final function. Is everybody okay? Okay, what's the value of the graph at f is equal to -3? I just used this from where I got somewhere earlier today. Just could maybe even like, for the purposes of this, we could maybe just assume it's gonna come down here, but on the test, I'll make sure that you're gonna have an actual value. So it's asking you what's the y value of the graph when x is equal to, what's y? That's what this is asking. Okay? And so we go find -3, 1, 2, 3. We could probably just assume it's gonna be something like right here. It'd be -5. So f at -3.
We don't have to like calculate it?
I suppose you could probably calculate it too. Not much is gonna change though, right? You're gonna cut that, yeah. You need a whole point, I think, to calculate it. Okay. Are we okay? Okay. So we're going to consider the function g of x. Okay, g of 5 is equal to 2. Determine where g of 5 is equal to transforms to. Determine where g of 5 equals to transforms to given the equation. That. So this might help. First things first, though. On the inside of the function, what's the problem? There's one major thing that we always have to check on the inside of the function, Dylan.
Like k value is separate.
Yeah, the k value is separate from the x. So the first thing I think I would have done here, or for sure I would have done, okay, and if you didn't want to use the round brackets, you could use squares. Okay, so that's now saying, okay, how would you like to do this question? Well, you could think about, like, you could try and keep track of all the transformations in your head, or you could write down the mapping statement, right? So the mapping statement is what? Let's look at what's being affected. Everything on the outside, it's very clear what's on the outside, right? That's on the outside, that's on the outside, and then you have two components on the inside. Inside, anything attached to the x or kind of on the inside is horizontal because it's closest to the x. Okay? And then anything on the outside just going to be your y, stuff that affects the y values. So if I were to write the mapping statement for this, it would be the transformation of an original point, xy. The way we are going to transform that point is with the mapping statement, which is what we're going to write here. Right? So the mapping statement, what's happening to the x values based on what you see there, right? So we have some components on the inside of the function. The inside is affecting the x values. So what's happening to those x values? First things first. The 3. What's that 3 controlling? Sophie?
Compressed by 3.
Yes, so compressed by 1/3, yeah. So we're gonna take the x values, compress them, or cut them in half by a factor of 3. And then what? Gabe?
Add 2 to it.
Yeah, so they're gonna, then all the points are gonna move to the right, and the only way to make those points move to the right is to add 2. Okay? And then the red stuff is your like vertical components, right? So on the outside, we're vertically reflecting, so all y values become negative, as well as you're gonna make all y values twice as big. That's that 2 that's out front. So we're gonna write -2y. Okay, and then the last piece is gonna take all y values and add 4 to them because the graph is gonna move up. Is everybody okay with the mapping statement? Everybody okay? You're separating stuff that affects horizontal components of the graph, x and y separately. And then you can take any point on the function and transform it using the mapping statement. Okay, so for this question, the x value, we're transforming the point 5 and y is 2. G at 5 is equal to 2 is the point we're transforming. Where x is 5, y is 2. So I'm going to input that into my function, and it's going to transform it. Okay, so transformation of the point 5, 2 yields 1/3 times 5 plus 2. You might have some fractions to work with there. Times -2 times 2 plus 4. Okay, so we're going to have some fraction work to do. So we're going to get 5/3 plus 2 for x and -4 plus 4 for y. Okay, so if I'm trying to add 5/3 to, or 2 to 5/3, what do I need? Oh,
You need common denominator.
yeah, what's the common denominator between those?
3.
Yeah, I can put a 3 in the denominator, but if I put a 3 in the denominator, I also have to include that factor in the numerator. So I'm going to multiply 2 by 3/3. Is that okay? So I'll write that line here. So I'm going to get 5/3 plus 2/1, which is what we're trying to add together. But I can't do that, so I multiply by 3/3. And we know that the y value is going to be 0 because -4 plus 4 is 0. Okay? So the final transformed point, oh, I'll write one more line. Okay, so we're going to get 11 by 3 and 0 is where that point would be given the transformations that have been applied to it. Is everybody okay? Okay, again, it's just like the first question. Major barrier for everybody is going to be identification of the transformations. It's where you need to spend your time. Again, I don't think it's the actual movement of things around on the graph or like any sort of multiplying or adding or subtracting that's going on in here. I think it's just the identification. You need to learn what A is, what the negative on the outside means, what the negative on the inside means. What's K, what's H, and what's Q. You got to lock those in. And what they affect. That's it. It's really only 4 factors that we're asking you to learn. 3 of which you did last year. We've just introduced the 4th one with the reflections. That's it. Okay? You have a bunch of experience doing this work already. Or you should. Okay? We've just thrown in one extra thing. Okay. So what function is this? And you could have drawn a little sketch for yourself if you wanted, right? It's the root x function, right? What happened to that root x function? Sophie?
Reflected vertically.
It got reflected vertically, and then what? Dylan?
Translated left 4.
Okay, so it's going to look something like this. Everyone agree? There's 4, and it's going to be opening down. Went left 4.
How is it off the x-axis?
Because it moved left. The +4 moved it left.
And then it got brought down.
There was no movement up and down. No vertical stuff. Because there's no Q value, right? There's nothing floating on the outside.
But then why is it down?
Why is it off the x-axis?
Oh, I see. Sorry. You're right. Sorry. I see what your question was. Thank you. Good catch. Everything I was saying was opposite of what I drew. Okay, is everybody happy with that? Okay, reflected and then moved left 4. Okay, so that changes. What's the domain and range? So let's talk about the domain range. It can take on any values of any values of x, but there is a restriction. It definitely does not go where? RJ?
Above 0.
That's the y. The y. Sorry, mate. You're right. But you're thinking right.
Sorry, it doesn't go below -4.
That's right, mate. So it doesn't go below -4, right? So we're gonna say x has to be greater than or equal to -4. Okay, and the range, RJ, what's the range, wait?
It'd be y is real numbers such that y.
This is the one you just said. It's whatever you just said. So it's less than 0, right? Yeah, that's it. Okay. Now let's determine. Is everybody okay with that? So that's a little bit of visualization. So that's the reason for no space there is you should try and visualize, okay, here's the base graph. There's not a lot of transformations there. Visualize the base graph, reflecting it, and then moving it left 4, and then conceptualizing what the domain and range look in that instance. That's not a lot of stuff to keep track of. Reflect, move left 4. What's the graph look like, right? And then write your domain range. So the value of f at 12. So if I'm substituting x is 12, looking for the y value, right? So we're going to get f at 12 is going to equal 12 plus 4. F at 12 is going to equal the negative square root of 16, -4. Okay, everybody okay? All right. What's the parent function here? If you call it the informal name, I'm not going to give you marks on that. What is it? Down?
If we call it what?
The informal name.
Don't call it the.
Don't. So like the last one, don't call it the hook.
Y equals the absolute value.
Okay, the absolute value is the good one. That's the answer. Absolute value, right?
Oh, what if we just wrote y equals?
Yeah, can we not do it?
Yeah, that's actually
All right, that's fine too. Yeah. Okay. So I don't think this is as well. You could probably actually do the domain range of this, just like we did in the last question. But we'll graph it first, and then that'll at least help you see the picture. So the red graph, the base graph is the absolute value graph. So it's going to be that V shape. Okay. That looks like that. This looks like this. Okay, that is f of x is equal to the absolute value of x. And then we're going to transform it. So starting from left to right, what do we see? Yes?
We have to reflect it.
You reflect it first, and then do you think you could do this in one step?
No.
I was asking genuinely. I didn't know if you could or not. We can reflect it and do them individually. That's fine. That's fine. These ones are simple enough transformations that you might be able to reflect and then move right or left and then up, down all in one go. Each point individually. I'm okay with that for this one. What I'm not okay with is when we start doing when there's all 6 transformations there, then you got to show a little bit more work. I don't think you can do that from start to finish. Okay. So reflect. 0 stays at 0, -1, -1, -2, -2. Okay, that would be the graph of f of x is equal to negative absolute value of x. Now we're going to move the graph. This will be the purple one. What's happening? you can give me both translations at the same time, Sophie.
Moved horizontally 1 unit right.
Yeah, and then
3 units up.
that's perfect. Okay, 1 unit right, 3 units up.
No biggie.
Okay. Is everyone happy with that?
First question I've gotten right so far.
Okay, we'll put the purple will be that final transformed graph. Okay, let's talk about the domain for a second. Are there any restrictions on the absolute values domain? No. So you're just gonna write x is a part of the real numbers. Is there any restrictions on the range for the for that transformed purple graph? Sophie?
Y is a part of the real numbers such that y is greater than or equal to 3.
Did you say what you said again one more time, please? Everything's good except one little bit. And you might have said it correctly. I'm not sure.
Y is greater than or equal to 3.
Okay, if it was greater than or equal to 3,
No, less than.
yes, very good. Right? Does not go above. Does not no part of the graph up here. Right? So it's a less than or equal to, which is good. Okay, if I were to transform this graph, t of xy is going to transform to what's happening in the x direction. Only one thing. What happened to that graph? What did we do to get to that purple graph is the question. And you're representing that in your mapping statement. Yes. I don't even know if you're looking at me with those things. All right.
It went up 3 units.
Okay.
Translated up.
It did go up 3 units, but in the x
Plus
direction.
3.
In the x direction, please.
Negative 1.
Oh, no, we're
Okay,
my
what
bad.
it was -1, but
Plus
what?
1.
Well, which one is it, Sophie? You've given me many answers now. It's plus because we added 1 to the x values in order to get it to go to the right. So it's x plus 1 is the only transformation there in the mapping statement. And what about in the y direction?
Plus 3.
Okay, is there anything else in the y direction?
Minus.
Where's the minus go? So remember what happened. We took all the original red points and then we made all the y values of the red graph become negative. That's the reflection. Yes, Owen?
Negative x plus 3.
Negative y plus 3.
Oh, yeah.
Because we're talking about y, but that's okay, right idea. That's your mapping statement. So you could substitute any value, any point on your absolute value graph into that mapping statement. It would spit out the points on the purple one. Multiple approaches to doing these graphs, right? Either listing and applying the transformations or using the mapping statement. Okay, so the transformations there would have been a vertical reflection. There would have been a horizontal right 1 unit, and then there would have been a vertical up 3 units. One more question, then I'll assign your test review.
We have to sign it?
I will assign you your test review. It's not a formal document. What are you signing? Signing your life away for a test. Everybody okay?
Why is mine melted
All right. One more. Okay, step one for finding the inverse says,
Really? What?
get rid of the function notation, right? So step one is get rid of the function notation. We're gonna write it like this. All right, there's a mark. Okay, step two. What's step two say? Ricky? Yeah, so we're gonna get x is gonna equal negative 1/3 y plus 5. Step three. Solve for what? Y again. Okay, you're gonna re-isolate for y. So x minus 5 is gonna equal negative 1/3 y. If I multiply both sides by negative 3, I'm gonna see that I get negative 3x plus 15 is equal to y. Okay, I'm gonna stop there for a second, make sure you can get your head around that. If you can't get your head around that, I'll show one more step, but I multiplied both sides by negative 3 in order to get the y by itself. If I multiplied by positive 3, I still would have had that negative sitting there. So I just did a couple things in one line. Okay, I don't know if that's freaking people out or not. Gabe?
Why didn't you do it with third instead of, because it's already divided, it's just, it's multiplying the lot.
So this is y divided by 3. The way we untie division is with multiplication. Because when I multiply the fractions out, that ends up dropping out. Okay? Yeah, big part of like a lot of people's like problems is like recognizing equivalencies. So again, I'll just bring to your attention, like this one comes up in grade 9 quite a bit. Those three things are the same. The location of the negative does not matter. Things like that, right? Like this is what I mean by these like statements of equivalency, like knowing that there's no difference between the way that you write particular things is actually beneficial with isolation and solving and working with math, okay? Last step is what? Step 4. Dylan?
Replace the y with the inverse function.
Yeah, it's important to recognize like the difference between the original function and the inverse. So we're gonna get negative 3x plus 15. That's you found the inverse. Okay? Now, question B, I think this is the hard part, really, quite frankly. Question B is just like input the x value and get a y value out. What is this? This is give me in words. This is going to say find the difference. You can write this or not. It's up to you. Between the y values that correspond you're finding the difference between the y values that correspond with x equals 6 and x equals 2 in each of their respective functions. That's all that's asking you for. So you're going to input the x value, get a y out, subtract the two outputs. Right? So f of 6. F is referencing the original function. F of 6 is going to equal negative 1/3 times 6 plus 5. That's going to equal... What's negative 1/3 of 6? That is, here, I'll write it, it's fine. Negative 6 by 3 plus 5. What's that? Yeah? So we get positive 3. Everyone agree? That would be the output of the original function evaluated at x equals 6. Okay? Now I'm going to find the output that corresponds with 2 for the inverse. So f inverse of 2 is, well, I know what my function is. It's negative 3 times 2 is my input plus 15. So I get negative 6 plus 15, which is positive 9. That's going to be the output of the inverse function evaluated at 2. Now I'm just going to combine these and find f of 6. I'll hit stop here a sec. Minus f inverse of 2. So, what's the output at evaluated f equals 6 or f at 6? It's 3. And I'm subtracting the output when 2 has been evaluated in the inverse function. 9. And so f of 6 minus f inverse of 2 is equal to negative 6.